Hello and welcome to our YouTube channel. My name is Shubhashish Singh Rehal and you're watching IAS Primers. Now recently, a new vaccine has come to the forefront, Corbevax vaccine. This is because the government has shown confidence in this vaccine even when it is undergoing phase 3 trials, meaning that it is yet to be available in the market and it is undergoing a last level testing. So the government has pre-booked 300 million doses of this new Indian vaccine, which is being developed by a Hyderabad-based company known as Biological E. And it is believed that it will be very low cost, which is being priced at nominal rate of rupees 500 for 2 doses. Now it is good to be optimistic, but remember, with reference to Covaxin, its MD had said that this vaccine will cost less than the price of the water bottle. And we all know that Covaxin presently is one of the most expensive vaccines, even more expensive than the AstraZeneca Covishield vaccine. So let's see what happens. Now coming to the mechanism of Corbevax vaccine. You can have a look at this particular virus, SARS coronavirus, this diagram over here. And this is basically the virus. And you can see on the top of this sphere, this red sphere or ball, you can see some spikes. Something is protruding out of it. We call this as spike protein. Spike protein. This is the thing that is responsible for the high penetration of this virus. So when a person comes in contact with SARS-CoV, this particular virus, in that case it is the spike protein that penetrates first, it starts to replicate, and then it releases the virus inside it, inside the ball. So it is the RNA code, RNA and N protein, which actually causes the damage. But it is the spike protein that spreads it, that makes it more dangerous. So in the case of Corbevax, it is said that it is a recombinant protein subunit, meaning it is made from a part of the virus. And which part? It is made from the protein. So this protein, spike protein, is taken and it is being added to the vaccines, and it triggers an immune response. So when a vaccine of this type, let's say Corbevax, is injected into the human body, then in that case the spike protein enters into the human body. It enters into the human body and it starts to replicate. But it is not dangerous because the virus is not there. The virus, the RNA code is not there, and therefore this spike protein is harmless. But in the process, what happens is the human immune system is triggered, and as a result it creates antibodies against the spike protein. So let's say in future a person come in contact with the actual virus. Then in that case, the immune response system would be triggered and the person would be saved from the disease, or at least the damage will not be as severe as it would require a hospitalization. So this was the working of the Corbevax. Now let us see how it is made, the making of this vaccine. Well, this technology of the recombinant protein, this making virus using this, it has been used since decades. It was available in the case of hepatitis B vaccines also. So the same has been utilized here. Then there is another company which is known as Novavax, which is developing its own vaccines, and it is awaiting authorization from various regulators. Now this vaccine is actually developed, the technology of the making of this recombinant vaccine is actually developed by a college or a school known as Bayer College of Medicine's National School of Tropical Medicine. For simplicity's sake, let's take it as BCM. So it is BCM which was actually studying these viruses from way back. It was studying the vaccines for coronaviruses using the help of SARS and MERS for decades. For over a decade it was studying it, and moment the SARS thing took place, they utilized this technology for making the vaccines for SARS-CoV-19 also. Now let us see how this vaccine is actually made. You can see a bear over here. You must be thinking by now, right? This bear. The making of this vaccine is very similar to the making of the bear. The bear is made by the fermentation of yeast. So when the fermentation of yeast happens, the bear is made. In the case of spike protein, in case of the vaccines, to the yeast, a recombinant protein subunit, that is spike S protein, is added to the yeast. So it is added to the yeast, it starts to replicate. So we have more and more of these S proteins or spike proteins. And as a result, we develop these vaccines. Now naturally, when this yeast and S protein, when this fermentation is taken place, we need to weed out or remove the yeast. So this yeast is removed and the vaccine is made solely with S proteins, and this is injected into the human body. Now coming to the comparisons, everybody is talking which vaccine is better, which technology is being utilized. So let us see the most important ones one by one. The first one is messenger RNA vaccines, also known as mRNA, and it is being used in Pfizer and Moderna vaccines. In fact, mRNA technology is something very new, and we can expect a mains question. We'll take it up some other day, this completely in detail. But let me cover this in a very short. So the mRNA vaccines, the M over here basically means messenger. It is based on mRNA. Basically, the cells work when they get some instructions. And these instructions are given by mRNA. So they are something like letters. It's something like a letter, and this mRNA tells the cells what to do, what not to do. So in this case, in the mRNA vaccine, the cells, let's say in the human body, when the mRNA vaccine is added, then it tells the human cells to develop spike proteins. It gives instructions to develop S proteins. So human body is being used to develop more and more S proteins, and as a result, an immune system is triggered. Just as I told you about the Corbevax, the same thing. Only thing is that now we are telling the human cells, the cells in the human body, to make S proteins. In Corbevax, we are adding spike proteins directly. So this is mRNA. Next is viral vector vaccines. So this is available in the famous Covishield, which is developed by AstraZeneca, and then Johnson & Johnson and Sputnik V. So let us see what are viral vector vaccines. To give you a hint, this vector, remember you must have studied about vectors for diseases. So things that carry the virus. So in this case, we do not use the actual virus. We use a modified virus to transfer the immune response. Let's say in the case of Covishield, we used a vector known as adenovirus, or also we can call it as common cold. So this is taken, it's yuck, but it is taken from the poop of the chimpanzee. It is taken from the poop of chimpanzee. It is weakened, It is weakened, and then to it is added S protein, spike protein. Clear? So when the vaccine is put on the body, when the injection is given to you, then in that case S protein is added with the help of adenovirus or a virus vector, and the immune response is triggered, just as in the case of Corbevax, the same thing. And lastly, it is the inactivated vaccines, the most famous approach of vaccination, that is to put either a weakened virus or a dead virus. In the case of COVID-19, we are adding dead virus. We are taking the virus, we are harvesting it and then killing it and then adding it to the human body. So when we add it to the human body, this killed virus is not going to do anything. It is not going to do any harm to the body, but it will trigger an immune response. So this is it. And it is believed that inactivated vaccines are likely to be better when it comes to the mutant-based virus, or also known as Berupia virus now, right? So inactivated vaccines. So these are the companies: Covaxin, Sinovac, Coronavac, China-based vaccine, and then Sinopharma, again China. Sino means China. So these are inactivated vaccines. So this is all we have in this particular section. And I'm pretty sure this would have helped you in clarifying your doubts about the various types of vaccines and also about Corbevax. Please don't forget to like, share and subscribe, and all the best for your preparation. Bye bye, take care.